Thanks for allowing me to be here. So my journey started with a company called Össur, which takes care of amputees. So it's Iceland's largest medtech company, and they create the prostheses. And what happens to people with diabetes is that they get wounds. These wounds, they get bigger and bigger, and sometimes people need to be amputated. And it's actually a big problem. So there's more than 500,000 people that lose their limbs around the world every year because of diabetic wounds. So people that have diabetes, 6% of them actually end up being amputated. So there's certainly a need for new technology in terms of wound treatment. In the old days, wounds were treated with gauzes. The gauzes, they keep the wounds dry. Then in 1955, we started to get something called moist wound treatment, which are products you put on the wound to make sure it doesn't become too wet and not too dry. And then in the first decade of this century, something called biologics emerged. These were products made out of pigs or cadavers or donated tissue from women. And these products really started to take off. Products made, for example, from amniotic membrane and pig tissue and so on. And when I returned back to Iceland in 2007 or 2008, I had my eyes set on establishing myself in medtech industry, and I had the opportunity to do that then. And so I started to think about, so what do we have in Iceland? So what do we have in Iceland that's not available in other places in such a scale or with such positivism? And I started actually to think about fish. And actually, initially I was talking about fish scales. Would there be some kind of regenerative action with fish scales that could be similar to the pig skin or the amniotic membrane and so on? And to my surprise, when I started looking at the fish, I realized that the fish skin has epidermis, dermis, and subcutaneous tissue, just like the human tissue. It has the same cell size as humans. Basically, the fish skin is identical to human skin. The only difference being that the scales that evolved over these 2 million years of evolution history to hairs. Otherwise, it's the same chemistry: elastin glycans, fats, proteins, collagens, insoluble collagens, hyaluronic acid, and other chemicals. It's basically identical to human skin. So what we do, is basically to take the fish skin, which is a byproduct of the food industry, and we process it. We remove the fish cells, and the result is actually a wound treatment product. So it's basically the fish skin with lots of small holes in it. They used to be occupied by the fish cells. We've removed the fish cells with our patented process, and then that product is put into the wound. The healthy cells, they will grow into the fish skin. They see all these small holes, and they will seek to reoccupy them and build new tissue. And so that's basically the invention, and that is guarded by multiple patents, which I will talk about in a moment. And we have different forms of the product. We have meshes, particulars products, different forms, and we evolved it into several brands. Brands for use in outpatient clinics, to use in burn clinics, in hospitals, and so on. In the essence, this is all the same product, though. It's the same technology. It's just with different pricing, different education, material, different papers, and different reimbursement, and so on. But going back to the material, so we are now in the market with the first generation fish skin, which is this decellularized fish skin. And the patents for this initial invention, they will expire in about 7 years' time. And in 7 years' time, then other companies, they will be able to produce fish skin. So the basis of the patenting system is teaching. So when you get the monopoly for 20 years, you get that in exchange for teaching the world how to make your product. So that in 20 years' time, when your patent has expired, everybody can use that to advance the quality of life and healthcare and technology and so on. So we are active in developing the second generation of the product and the third generation, because when the first generation will start to expire around the world, we have the patent issued in about 50 countries. So when the patents start to expire, we want to be in the market with the second generation product. It's going to have more features. It's going to have different color. It's going to be easier for the doctor to distinguish in the wound. It's going to be antimicrobial, so less likelihood of infections. And we will have brought that through all our marketing channels. And of course, that new technology will have 20 years time of patents. And so you can go with our expired patent, you can copy our technology from the expired patent, and you will have an inferior product. Or you can buy the product from Kerecis, the Generation 2, with its new features, with giving the company 20 years of monopoly for that invention. So this is very research-driven. This is why a company like Kerecis needs to continue to innovate. We need to continue to deploy funds in innovating, to create new technologies, new features, new marketing stories, but also, very importantly, new patents. Because if you don't have patents, then the big multinational companies, they will just walk over you. And actually, we are also working on our third generation of product also, which has impregnated cells and has a little bit different technology, with the fiskin being the host, but with some other features in it. And that product will have 20 years of lifetime too. But talking about our patenting strategy, so patents have always been very important for Kerecis. So actually, when I started thinking about using fiskin in tissue regeneration and wound treatment, actually the first person I talked to about that was actually my wife. But actually the second person was the patent attorney. So think about that. So a guy called Ernst Kenny, who I had worked with in Össur and several other medtech companies where I was an employee. And the surprising thing was that there were no patents that were either expired or current discussing fiskin and the use of fiskin or decellularized fiskin in wound treatment. So that really was interesting. And there were however, there were thousands, even tens of thousands of patents discussing use of products from mammals, including humans. But nobody had thought of using fish. And I guess it's because fish looks very different from us. I mean, so doesn't have hands or feet or head or a big brain. So you just think that the fish is something totally different. But actually, the fiskin is identical, and that is actually an amazing fact, and is really actually benefiting Kerecis today. And actually the patients, of course, because now we have these products out there and we are treating thousands of people every day with our technology. But about the journey, and Carl talked about here before about the provisional patents. And provisional patents, they are very important. So I myself, I have filed hundreds of provisional patents, and I am the holder of about 150 patents that are either issued or pending. And people think, or small startups, they think that patents are expensive. But actually patents, they are not expensive. They're actually initially very, very cheap. You can just write it yourself, you put it into an envelope, you send it to the patent office, costs less than $100, and then you have a patent pending. And when you go to investors with your fancy slide deck, when you're raising money, you can say, yeah, I have a pending patent. And that is very powerful. And then after a year, you need to file a patent, then you need to get some assistance in structuring it and writing claims and so on. So basically you have a whole year where you can just basically claim that you have a pending patent, but very little cost. And actually there is not much cost when you file the structured patent. You file it in at the patent office, it costs you a few $1,000s. Nothing happens for a year or 2 or 3, and you still can say that you have a pending patent. And then you need to decide what countries in the world you want to prosecute it in, and you just select all the countries in the world in it, and about 150 countries. And then the initial examination starts, and in the country you filed it in, and then the cost starts to trickle in. Then you need to start to pay your attorney for prosecuting the patent, interacting with the patent office. And then you start to get notices from countries around the world that they want to start to examine your patent. And then you need to revise your patent list, your country list. And then you cut it down. And In the case of Kerecis, we cut our core patent down to 50 countries. And so we did prosecute it in 50 countries. That costed more than $1 million, which was a huge expense for Kerecis at that time point. And some other patents we have prosecuted in fewer countries. So it depends on the commercial value of the patent for the company. So we have our core patent for this first generation issued in 50 countries. And for the second generation of products, we have 6 pending patent families around different aspects of the technology. On the core use in wounds, but also for other uses in other medical fields, for example, in breast reconstruction and for other indications. And initially, we go very wide. We just claim that we want to file it in all countries, and then we do a reality check. We check how the research is going versus the disclosures that we made, and then we cut down the scope of the patents. And we have an in-house person. We have 2 people that work on patents in Kerecis, and then we use an outside counsel, which is a company called VN Law in Utah. We do file our patents initially in the US because of the provisional pathway. I know there were some recent changes here in Europe on provisionals, but I don't think that Europe allows for provisional patents. But I might be wrong on that though. And then the third generation. So there's less that I can tell you about that, because here we are actually still in the provisional space, and we are still generating ideas and attributes for the products. But these patents and the ability to talk to investors and tell them I have a patent pending was very important, and it's still very important for us. And so when Coloplast did acquire us last year, it was very important for them that our technology could be used for the coming years in the countries where they are active in, and also that we had a strategy in place to what we would do when the first generation of the patent started to expire. And I'm absolutely sure that our growth and we would not have been as steep if we didn't have issued patents and we didn't have the protection and the monopoly for our invention in our main market where we're mostly active in the US currently, which is the US. And just a point here which I like to talk about is that of course, Icelandic, I'm very proud of our fishing industry and our sustainable fishing industry. And I'm very excited about the fish farming and how we are growing the wealth that we will all enjoy from the ocean. But talking about Kerecis and just putting the number of Kerecis into perspective. So this year, the revenue of Kerecis is going to be, this calendar year is going to be about $200 million. And the total export value of codfish in Iceland is $1 billion. So all the export of fish from Iceland, codfish from Iceland, is $1 billion. And without catching any more fish from the ocean, then we actually increase the value of that by 20%. And all of this is based, of course, on research development, clinical trials, and importantly, patents. And that is basically what I wanted to share with you here today. So, thank you.